Hey, so today I'm going to talk about continuous delivery in a microservice infrastructure using Google Container Engine, Docker, and Travis. So just to have an idea, how many of you knows what like Google Container Engine is? Kubernetes as well. Okay, cool. Okay. So the idea is that I want to show you basically how you can use Travis for testing and deploying application as a Docker containers on Google Container Engine. So I think like most of you knows what continuous integration is, but for the one that doesn't know, basically it's a software engineer practice in which isolated change of the code can be immediately tested and get, so far you can get like a rapid feedback if you have introduced an error. And if so, you can actually identify and correct the error as soon as possible. Travis or like CircleCI and etc. are like basically tools that can be used to automate the testing and the building phase in your continuous integration pipeline. So continuous delivery basically it goes basically a step farther than continuous integration and basically ensure that every build can also be deployed into a production-like environment. And eventually, you can run integration tests in that environment. So Google Container Engine, for who doesn't know what is it, is a cluster manager and orchestration system powered by Kubernetes. Is basically a sort of Kubernetes, managed Kubernetes, and is a part of the Google Cloud Platform services. And the great thing is that Google Cloud Platform also offer a private registry for your Docker images, which basically allow you to easily store and access your Docker images within Google Container Engine. Why I choose Travis is because Travis integrates very well with GitHub, and it runs tests in isolations. So basically, you don't have to manage your own infrastructure, which is pretty great when you're a startup and you don't have a lot of time to, have like a really big DevOps team or set up like a Jenkins and stuff. So my concept here is kind of easy, but it's basically you have like features and hotfix branch. So I take like we start like from the idea of Git flow, like the Git flow, but instead of having like release branches, you don't really have. You only have like master, eventually development if you want to have like staging and production environment, and then you have features and hotfix. Features for developing like new features and hotfix to do like some fix on the production code. So the idea is that you commit and push code into the feature and hotfix branch. Travis basically run the test on the new code that you commit. You try to commit as much as much as you can, so that you basically commit all of the time really small changes. And the idea is that if the test pass, you can actually open a pull request for merging the feature or the hotfix branch into master. Travis then run the test over the merged code, and if the test pass, basically a Docker image is built, pushed into Google Cloud Registry, and finally deploy into the Kubernetes cluster. Okay. I need to do a demo now. So basically in this demo, I want to show you how I can basically create a Node.js app, Dockerize it, and deploy it into a Kubernetes cluster managed by Google, and finally like set up a continuous delivery pipeline so that every change in your code can be automatically pushed and deployed into the production, into your production-like environment. So, first of all, we need to create a Kubernetes cluster. So I will log into my Google Cloud Platform console. And so basically, this is. So basically now I go to Container Engine. So if you never try Google Cloud Platform, basically they offer like $300 trial credit, so you can just set up and do the same for free. But if you have it, like just go through Container Engine, you select Container Cluster, and basically there is this option here, Create Cluster. And so basically what you need for creating your cluster is the cluster name, of course. You select the zone where you want to deploy your cluster. And for this zone, it means the master zone, because then you can actually replicate your cluster over multiple zones, but you need to select basically the master zone, where your master, which is the entry point of your cluster, is going to be host. So I'm going to select, like, for example, US East 1B. The size of the cluster, for this demo, I will just like, no, 59 is too much, 3. The machine type, which you can select whatever you want. Small, for me, this demo is enough. And then the node, something happened to the microphone again. And then basically the node image. So the latest one is GCI, and it contains the latest update, and it is the most secure one. So if you have to set up the cluster from scratch, just use this one. And then you have like a couple of other options, like for example, additional zone for your replication. You can enable Kubernetes alpha features, which are pretty cool, but unfortunately, like, if you try to do it, they are not really well supported, because like they say basically that if you activate these features, the cluster is going to be delayed in 30 days. So it's good for like testing, but definitely not for production. You can basically give some other permission to access to other Google Cloud Platform services from the nodes in your Kubernetes, like for example, Cloud Data Store, Cloud SQL, et cetera, et cetera. I don't need any of those for this demo, so I will just like create my cluster as it is. So I already created the cluster because it takes like 6-7 minutes to do it, so I already created one. But if you go ahead, create, it does exactly what's next. So here's the cluster I created already. And when I try to click basically on connect, it gives me like a command line. So to operate with Kubernetes, Google Container Engine, and Google Cloud Platform, you need to install gcloud SDK. It's a Python SDK. It depends which operating system you're using. Like with Mac and Linux, it's pretty easy. I never tried with Windows. But yeah, it's just like, if you Google it, you're going to find out how to install the command line. It's pretty easy. So I'm going to actually show you what Kubernetes looks like. Fortunately, let me see. This is too much. Yeah, this should be better. So I'm going to show you basically what Kubernetes looks like through the Kubernetes proxy. So first of all, I connect to the cluster. Awesome. And here we go. So basically, this is what Kubernetes is. It shows you basically all the resources that you have in the cluster. And you can have like deployments, which are basically, a deployment represents a service that you create and you deploy in your cluster. A pod is basically the smallest unit that you have in Kubernetes, and it can be built on several containers. So basically, you can see a pod like the smallest unit in Kubernetes, and a pod can be one single container, but it can be as well multiple containers linked together that they have one single life. So basically, if one of these, let's suppose you build a service that has like a node application and a Redis server, and you can link those together, and they have to live at the same time. So if your node app fail or your Redis server fail, the pod restart both of the containers that are constituting basically the pod. So here basically you show me the deployment that I already have. I already deployed the demo, which I'm going to basically deploy again, just for like for this example. So basically, to go ahead, we need to get the cluster credential. And to get the cluster credential, you can basically run these commands here, or the command that I already run. So basically here, if I run these commands, basically what happened is that I set my project to tribe testing. I set the cluster container to cluster Codito January 2017, which is my cluster. If you guys don't see, just let me know. Which is basically my cluster name. And then I go ahead and basically I set up the zone, which is US East 1B, where is the zone in Google Cloud where my container, my cluster is hosted. And then finally, I get the credential for the cluster. Next is I create basically a private GitHub repo containing my application code. I have already did it. I already done this, and it's this one. So in this repo, basically, I have the resources, the Travis resources that I need to run to build basically the continuous integration environment. And at the same time, in the SRC folder, I have my Node.js application, which is like a very basic hello world. And what's next is that you need to create and add a Docker file. So a Docker file is basically the instruction that Docker used to build the image of the to build basically Docker image. And for this example, like the Docker file is pretty easy. I just say that I'm gonna try to make it bigger. I basically just say start from node 7 runtime, expose and open the port 8080 of my container, copy all of this source code, all of the code in this repo into a folder from root of the operating system called Codito, move into the Codito directory, and then create a default entry point for when you start the container, which is basically an entry point that run the command node src server.js, which basically start the Node.js server. Next, basically, is that what we want to do is, after we create a Docker file, we want to build and test the Docker image. And to do that, basically, did I say that? Yeah, here we go. So basically, I will just build it again for this test. So I run this command. And basically, this command is docker build -t, the name of the image. In this case, basically, I specify gcr.io tribe testing, which is basically saying it's where I want to deploy, I want to push, sorry, the Docker image. And I tag this image as a pre. So it's just like, because after when I start the continuous deployment, the continuous delivery pipeline, it would be tagged with the Travis CI commit. But for now, I will just create like a random tag, just pre-tag, just for bootstrapping the service. Then like I can test my image doing like running this command, basically docker run, exposing port 8080. I already tested, so I believe it's working. You should trust me. What's next is that after this, I want to push this Docker image into GCR. And to do that, basically, I use the command gcloud docker push. When I do that, basically, I'm pushing my image into the GCR. The layer exists already because I pushed it before, but so we can actually speed up this because it can take a while. If the image is big, it can take maybe like several minutes. So it says that pre has been pushed. The digest is like an hash, and the sites is blah blah blah. So after this, what we want to do is that finally we want to create the Kubernetes deployment, and we want to as well allow the traffic to the application. So these are the commands that you can use to create the deployment using command line. You can also create a Kubernetes file, which is a YAML file, and then using the you can use the command kubel sctl apply -f, which is like from file, and then you specify the configuration file, and it basically does exactly what these two command line do. So the first command line basically create the deployment and say that the deployment, the container of the deployment has a something on port 88 is going on. And the second command line basically expose the deployment with a load balancer type to the, basically allow the external traffic through using a load balancer to the container that is running for that deployment. And basically like in Google Cloud Platform, that second instruction basically create a network load balancer which map all your traffic from like, let's say, port 8080 to the port 8080 of the containers that are running in the deployment above. I already created the deployment, but I'm gonna deploy again. So to deploy again, basically, what I need to do is that first of all, I need to delete my previous deployment. So here we go. So this is the deployment, basically is what it looks like after the deployment. I'm gonna delete this one and I'm gonna redo it so that you can actually see it, what's going on. So I need to delete as well the replica set, which are created together with the deployment. And a replica set basically ensures that the number of pods that you want to run into the cluster for that deployment is maintained. So if actually, for example, a pod died, the replica set will ensure that the pod will restart, or will you basically can scale up and down, and all of this kind of operation is handled by the replica set. And if you delete a replica set, but you still have the deployment set up, basically the deployment ensures that your replica set exists. So in terms of dependency, you have like pod that depends from replica set and replica set that depends from deployment. And here delete the pod. So now my cluster is empty, nothing is going on. it's gonna disappear at some point. So I do the deployment now. And as you can see here now, oh yeah, I know why. I made a mistake. So basically, I specify tribe staging in the project, and the project is actually tribe testing. So that that image doesn't exist. Just delete this. There we go. So deployment created. And yeah, now it's running. The last thing here is that now I want to allow external traffic because for the moment, basically, this deployment here is only accessible inside the cluster. In fact, like, you know, it has like it doesn't have basically any public IP address from which I can access from that site. And to do that, basically, I use the second command, which is like Kubernetes expose deployment type load balancer. It does exist already because I created before. So basically, you always create a network load balancer, which I need to delete because it's called like the same. Here we go. Delete this. And then I delete the service here too. Because basically, it creates when you expose a service, it creates when you expose basically a deployment, it creates a service and it creates as well a load balancer connected to the service that you create. So now I delete this. And when I do expose deployment, yeah, the deployment is exposed. The service has been created. Okay, so as soon as like the load balancer is created, you will be able to access to the service from that side. And in the while, basically, I'm going to show you how to set up Travis, which is basically our final step. And this is probably actually the most interesting part. So to do that, basically at this point you have the application running in the cluster, is exposed outside. Now you need to enable basically the repo on Travis to allow Travis to run integration test over the code. So, is it? All right. So this is like you can sync here from your GitHub. So you need to link your the Travis account to your GitHub, and here is my repo for this project. I already activated. So I don't need to basically switch again, it's already switched. But what's next is basically that you need to do some setup here. And like, you need to go into the setting. And once you go into the setting, what you need to set up here is, the most important is to set up a variable which is called gcloud service key, and which basically contains your the credential to access to GCR and Kubernetes. And to these keys, basically, you can get it from the console. You can go here and do API Manager. You go to Credentials. And basically, you do like create credential, service account key. You select a service account. In this case, I just have like a default Computer Engine default service account. You select JSON as a format. You do create. And you download this JSON file. So what's next here is that like you do this command, cat name of the file, and you pipe into base64 command, and you get this base64 output, which is basically your JSON encoded in base64. You copy this, and you go back to Travis, and you create a gcloud service key variable here, and you paste your base64 value here, and you do add. I already added, so I'm not going to do it again, but this is just an important step, because this key is going to be used by your Travis YAML file, and more precisely from your deploy bash file that your Travis YAML file is going to call to basically build a Docker image, push it into GCR, and finally deploy into, update basically the image into, update the image of the deployment so that basically the new image is going to be used by the deployment in the cluster. So once I have done this part, what I want to do is create a Travis YAML file and a deploy.sh file. And the Travis YAML file, basically, it looks, for this Node.js app, looks something like this. So you specify the Node.js runtime, and you set up, you install the Google Cloud SDK. You set up like a bunch of global variables, including the project name, the cluster name, the compute zone, etc. And you install here the SDK. You install the NPM modules. I don't have any tests for this, but here you will run, for example, npm run test, and then you have like, in your package.json file, you're gonna have like a bunch of commands for running your unit tests. And here, I install the Kubernetes command for gcloud. And at the end, this is the most like important part, is if the code committed is in master, which means like, for example, once you merge your feature or your hotfix branch into master, you run as well a deployment script, which is contained into the folder resource deploy sh on branch master. You can have it like, for example, on development, if you want to have like 2 separate clusters, one for staging and one for one for production, for example. And the deployment SH script basically is very simple. So the first 2 lines, you build the Docker image, you tag the Docker image, you tag the Docker image, and what's next is basically you use that gcloud service key that we set up as a secret in the Travis project, and we decode the base64 into, and we recreate a gcloud service key .json, which we will use in the next line with the command gcloud out activate service account from file, so that basically we get the authorization in that environment for pushing the image to GCR here. And finally, basically update the deployment image for the deployment that we create before. And once you got this set up, the only things that you need to do, because it took me like really a while one time to understand why my script wasn't working, is that I forgot to give this script the execution permission. So the thing is that if you create this and you don't give execution permission, once you commit it, Travis is gonna try to run it, but the script doesn't have execution permission, so it will fail, but it won't give you any real specific error. It will just say fail script, script fail. So it took me a while to understand it, but at the end I did it, and it was this. So don't forget to run cmode plus x over this file before committing. And basically, at the end, you commit everything, and if you made everything right, it will basically work. So I'm gonna actually show you this all together in action. And let me see now if the load balancer has been created. All right, so this is actually the external IP address. So hello world. So now I'm gonna update the code, and I'm gonna push it to GitHub. And if all the pipeline has been properly set up, it will deploy the new image. So great. So I pushed it straight away to master because like it's just a demo. So. I hope I did everything right. All right, so if we now go to Travis UI, yeah, have something's going on. So basically, yeah, this is the new build is waiting to get built. So as soon as this finished, back here I should have like a different text, which is the new text that I wrote and commit. So this can take like maybe 2 minutes, 2-3 minutes, maybe more if because I'm using like the free version over like my account, so it's just like slower. It hasn't started yet, so I'm very confident it will work. In the while, do you guys have any questions about what I've done, or because maybe I went very fast, so. Oh yeah, so basically, so if I understood, like you ask what Kubernetes proxy does in real. All right. So for what I know, because of course I didn't code the command. So you basically have a cluster, and you have a master, which is your entry point into the cluster. The proxy command basically is exactly what proxy means. So basically create a link, a proxy from your localhost to the master. And then you also like gives you basically a graphic user interface, which use the Kubernetes APIs, which is hosted into the master. So the master exposes an API, which can be used from the proxy. So the proxy does a proxy, and as well, it comes with a GUI, which uses the API. And you can have like a visualization, basically, of what's going on in your cluster, including like the nodes that you have. I closed the command, so. Including like the nodes that running in your cluster, the volumes, the persistent volume you have, the namespaces, deployment, replica set, services, storage. So all of these kind of things. Can you do it up? Can you access it directly without going? Yes. So you can using the gcloud command. So for example, you can do like, so I use the proxy only for the GUI, basically. If you want to get the list of deployments, you can do like something like, yeah, something like, for example, this should work. Yeah. So it gives you like the list, for example, of deployment that you have. Same if you can do like pods. You get the number of pods. And let me see now if the build finished. Yeah, it did. So it say that the build passed. So if I go back here, yeah, it updated. So basically, as you can see, Travis run basically that deploy.sh script, which basically build the Docker image inside the Travis CI environment, push it to GCR, and finally update the image in the deployment of Kubernetes. And the last thing, so if I go here, container engine, and I go to container registry, here is my latest pushed build that I made like 2 minutes ago. It's tagged as well with the latest tag, so that the reason why I always use here. So when I create the tag, I basically first of all create the image using the Travis commit, but I as well tag it as a latest. And the reason why I do this is because if for some reason I delete my deployment and I create a deployment from scratch, I will use the latest one to build the deployment from scratch, basically. So it's a way to, I don't think you need to remove a deployment, but if you have to, you have it. I think that's it.
You didn't show us, I guess, the hook you have between GitHub and Travis. Sorry? Because when you pushed the deployment, when you committed the new text, it triggered Travis to deploy.
Yes.
So you have a hook between those that you didn't show us, I guess.
You have,
a hook. You have a hook between your repo and Travis.
Yes.
Okay. You didn't show us these,
so,
did you?
No, like I mean, I'm not sure I understand your question, but if I do, basically, when you push the code, when you do a commit on GitHub, GitHub will make a hook on Travis.
Yeah, because you wrote it. You defined that.
Yes.
As a hook. Okay.
Yes, I define it basically when when you sign up with Travis and you enable the project, he automatically. That's why I say I use Travis, because it does this for you. Basically, they exchange messages and Travis connect with GitHub. He set up a SSH key for accessing to it, and yeah. I mean, you don't have to do it manually. It's just that switch that I show that you do it and it does everything for you.
Yeah, and the second question is the key that you base 64 encoded and then converted to JSON is a SSH key public, I guess.
No, is yeah, I show you actually. It's so there is a certificate, there is a private key, of course, but there are as well like other bunch of information like project ID and like client certificate, all of these things. You have like the client email, which is basically the ID of the service account that you use. And then, yeah, there is the private key.
If I want to deploy everything committed on the develop branch in a specific cluster and everything committed on master in another production cluster, can it be expressed in one single deploy.sh, or do we have two files?
No, I mean, maybe yes. I use, at Tribe, we use two scripts. Okay. So we have like deploy staging and deploy production. We have only one Travis YAML file, of course, but I actually can show you what it looks like. Let me see. So, you know, we have like, this is a service. We have a tribe for sending notifications. So as you can see, you have like deploy staging, deploy production, and here, you know, the variable change. So you have stg in the staging script and prd for the production in the production script. I mean, I'm sure you can somehow making only one script, but I mean,
what's the point? Okay.
Yeah.
Okay.
It's easier like this, and then you can see like in the Travis YAML file. Here we go. We have like, you know, as we set up both of variables for staging and for production.
Okay. And second question, if I may. If we follow the Git flow and we have multiple developers working on multiple feature branches at the same time, and if we still want to deploy every time someone makes a commit on one of these branch, does every developer has to have his own cluster, or?
So the idea is that, okay, let's suppose you have, like, for example, your development branch for staging, your production, your master branch for master, and then you have a features branch for like doing like new features development. So generally, like what we do, then like it can depends from like company and company, but what we do is that like every developer works on his own branch, So because we don't have like a really massive team, so if I working on a specific feature, it's gonna just be working on that specific feature. So I will push code. I will commit code maybe 5, 6, 7 times a day, but that code is not deployed. That's why basically there is something maybe called continuous deployment, but we don't do that. It's more like what we do is more continuous delivery, so we ensure that what we push into master or development is deployed. So every time that we commit into the feature branch, nothing gets deployed.
Okay.
So it's deployed only when I'm going to open a pull request from the features branch into development. And if the test passed, I merged the feature branch into development. And at that time, the code pushed into development is deployed into the cluster.
So we can have Travis build and run tests every time a commit is made on a feature branch.
Yes.
But it only deploys on development or on master.
Yes.
Okay.
In fact, like if
Thank
you have like the commands. I showed you before, like you have like on master. When the deployment, you do it only on master or on development. Thank you.
Que la famille.